Hi, you guys. This is my bat. His name is Stanley. He is very old and I've had him for a very long time, but I am going to swing him today to demonstrate Newton's first, second, and third law of motion. Lovely sister here, her name is Summer. She is going to be swinging the bat for us today to demonstrate how Newton's first law is incorporated with a softball swing. Newton's first law states that an object in motion must stay in motion, and an object in rest must stay at rest unless acted upon by an unbalanced force. Summer, if you may put the bat on top of your shoulder. Right now, the bat withholds potential energy because Summer, our lovely model here, has the potential to swing the bat and create motion. Also, the pitcher also has potential energy because he's getting ready to pitch the ball. When he pitches the ball is going to be moving in the air and it's going to be withholding kinetic energy. Summer, if you could swing for us, please. Oh, what a lovely swing. Okay. Summer's swing right there. She was moving. The bat was moving, and so was her body. Her body and the chemical compounds in her body had kinetic energy because they were moving. The bat also had kinetic energy, and it was using the energy that it was withholding when she had it on her shoulder. Also, if Summer was to hit the ball pitched at her, the bat would be acting upon the ball and would represent an unbalanced force. This unbalanced force would create kinetic energy. Okay, what a miss. Okay. This unbalanced force, watch as she tries to hit the ball. Yay, she hit it. So as she hit the ball, that was the unbalanced force acted upon the ball and it created motion, which gave it kinetic energy from its previous potential energy. This was the first law of motion. An object in motion must stay at motion, and an object at rest must stay at rest unless acted upon by an unbalanced force. My dad, Greg, he is going to be taking the squishy ball and he is going to throw it resembling a softball player with a softball in his hand. Within this, we are going to be demonstrating Newton's second law of motion, which states that force equals mass times acceleration. My father, Greg, is going to be the mass. He is approximately 185 pounds. With this force of his body, he is going to wind up and he is going to throw the ball with all of his force. The ball accelerated in the air, and so we took the acceleration times the mass of my dad, which is 185 pounds, and this is how we got the force of the softball. This correctly demonstrates Newton's second law of motion, and thanks to my dad, Greg. Summer is going to run, which is going to represent Newton's third law of motion, which states that every action has an equal and opposite reaction. Summer is going to take off in a sprint, resembling a runner running from home to first base, if you will. That was not my idea of a sprint. However, Summer's force of approximately 122 pounds took off running. So her action of running created motion. So Summer was running, and so her opposite reaction was motion. This demonstrates Newton's third law of motion. We thank you for listening to our presentation.
Yeah, see you later.